Okay, so for example, we have a problem, a system of linear equation in this form. So the problem is find the solution of the following system of equations using Kramer's rule. So we have 2x plus 3y minus z equals 5, 4x plus 4y minus 3z equals 3, negative 2x plus 3y minus z equals 1. So using Kramer's rule, what we need to do is we will write the system of equations in a matrix form. A x equals b, just like what I've said on the previous video. Okay. So what is our A matrix? Our A matrix is 2, 3, negative 1, 4, 4, negative 3, negative 2, 3, negative 1. These values are simply the numerical coefficients of these variables. Okay, 4, 4, negative 3, 4, 4, negative 3. Then we line up our unknown variables x, y, z. Okay, then we line up as a column vector our constants 5, 3, 1. Okay. Okay. So to solve this using Kramer's rule, the formula is x, or the unknown matrix, is equal to the determinant of 5, 3, 1, 3, 4, 3, negative 1, negative 3, negative 1, all over 20. So how do we get 20 and how do we get this above? Okay, first, okay, so the general formula for getting the unknown x or unknown coefficients is this: x of j is equal to the determinant of a j prime all over the determinant of a. Okay, how do we get the aj prime? Aj prime is the matrix formed by replacing the jth column of the matrix with the column vector b. Okay, so it says we will replace the jth column of the matrix. Okay, so for x, we refer to the first unknown. Therefore, we will replace this the first unknown. So we will replace this first column by this B matrix. So that's why this 2, 4, negative 2 will be replaced by 5, 3, 1. See? Okay, 5, 3, 1. Okay. So this 2, 4, negative 2 will be replaced by 5, 3, 1 over here. So that's the definition of aj prime. Okay. So when you want to get the y unknown later, which is the second unknown, we will replace 3, 4, 3 with 5, 3, 1. So on with the z, the third unknown, we will replace the third column by 5, 3, 1. Okay? So let's do this. Okay? So the aj prime for now is this: 5, 3, 1, 3, 4, 3, negative 1, negative 3, negative 1. Okay, how about 20? How do we got 20? It is simply the determinant of A, which is the A matrix here. Okay, the A matrix here. Okay, so how do we get 20? Simply 2 times 4 times negative 1, right? Plus 3 times 3 times negative 2. Okay, that's the way to get the determinant of the matrix. So we will have a detailed computation of that here. Okay. Okay, so for example, on how do I get 20? Okay, I'll choose another color. Okay, so that is this one. Get the determinant of that. That will be 2 times 4 times negative 1 plus 3 times negative 3 times, okay, 3 times negative 3 times negative 2 plus 4 times 3 times negative 1 minus. So we're done going on this direction. Then we'll go now upwards. Okay, this one. This direction. Going there, going there, going there. So that is negative 2 times 4 times negative 1 minus 4 times 3 times negative 1 last minus 3 times negative 3 times, so this one will be over here, so that's 2, and you should get 20, okay, which is this. So that is the determinant of this whole matrix, and you do the same for this matrix. Okay, so how do we get the determinant of this? So that is determinant of aj prime is equal to 5 times 4 times negative 1. Okay, so 5 times 4 times negative 1. Okay, going downward to the right, going southeast. 5 times 4 times negative 1 plus, okay, plus 3 times negative 3 times 1 plus 3 times 3 times negative 1. Then minus to all going upwards, as you notice, right? Where's my pen? I can't find it. There. So once you go northeast, the sign will be negative. Okay, if you notice, right? Okay, and then minus. So 3 times 3 times negative 1 minus 1 times 4 times negative 1, okay, minus 3 times negative 3 times, okay, that will be 5. Okay, so what's the answer for this? And the answer is 20 also. Okay, so that is also 20. Okay, that is also 20. All right, so next, so we will repeat the same process for y. Okay, so I can copy this, but before that, let me summarize or conclude what will be the value of x. So that is will be 20 over 20 is equal to 1. Okay, using Kramer's rule. Okay. Okay, so let's now copy this. Okay, how am I going to do this? Okay, so I copied the page and now it's time to solve for y. Okay, so I'll just replace this. Then I will be replacing this. I'll replace, so this is correct. I'll replace this. Okay. Okay, so I'll replace this one also. Okay. Okay, and of course, our value for y will be different. Okay. Okay, so let's do this. So our y now will be equal to determinant of, since we are now on the second unknown, replace the second column by 5, 3, 1. 5, 3, 1, which is the B matrix. And oops, I need to, okay. Okay, so I now replace the second column by the B matrix. Okay, and I'll retain the original first column, 2, 4, 2. Okay, so the same process. Let's find the determinant of this, AJ prime. Okay, so I'll rewrite. So that will be 2 times 3 times negative 1 plus 4 by 1 by negative 1 plus 5 by negative 3 by 2. Then all arrows going up will be negative, minus 2 times 3 times negative 1 minus 4 times 5 by negative 1, and lastly minus 1 by negative 3 by 2. Okay, so let's find that value. Okay, I made a mistake. So this should be negative 2. Okay, I forgot. So I need to correct this here and this here. So you operate that, you will get 40. Yeah. So this should be 40. Therefore, 40 over 20 is simply 2. So y equals 2. Okay, so for the last part, I'll be copying this again. Edit, select page, copy page, and then okay. So I'll erase this again. Erase this again. Okay, so for solving Z, the last unknown, so I'll be doing the same thing we did earlier. So Z is the third unknown, therefore the third column will be replaced by the B matrix. So this becomes 5, 3, 1. And then this will be 3, 4, 3, the original one. Okay. Then, so this will be the AJ prime. Get now the determinant of that. So that will be 2 times 4 by 1. Okay, do I miss something? Okay, 2 by 4 by 1 plus 3 by 3 by negative 2. This will be negative, plus 4 by 3 by 5. So, and everything going to the up, going up, northeast is negative, minus is minus, minus negative 2 times 4 times 5, 2 times 4 times 5, minus 4 times 3, minus 4 by 3 by 1, last minus 3 by 3 by 2. So what do we get that? Okay, so what do we get? It's 60. Okay, this becomes 60. So 60 over 20 is 3. Okay, so that will be our Z. Okay, so that's it. So to conclude, our unknowns is Rx equals 1, y equals 2, finally z equals 3. So this is the solution. So that is using Kramer's rule. Okay. Now using Excel, so as explained in our manual, okay, so we will do that using Excel. Okay. Okay, this one. There. So I also, you will create a matrix in Excel for the A matrix and the B matrix. Okay. So our A matrix is this, as we did earlier. The B matrix is this. Okay. And again, the general formula for that in a compact form is A x equals B, right? Okay. Then to get x, which is the vector of the unknowns, so simply x is equal to A inverse B. That means we need to get first the inverse of the A matrix. Then we will multiply that with the B matrix. That's why in this figure, I got first the inverse A, okay, and then I multiplied that inverse A with the B matrix to get the matrix of the unknowns. Okay, so I'll show you this manually. But first, as a heads up, how do we get the inverse of A? So using Excel, you do that by using the MINVERSE function. Okay, yeah, okay. And to multiply these two matrix to come up with this, you will use M mult formula. Basically, that's the two main formula to use in Excel. Okay, so I'll open a matrix here, an Excel here rather. Okay, then let's do the A matrix. So that is 2. How's that? Numlock 2, 3, negative 1. Zoom in. Okay. Next is 4, 4, negative 3. 4, 4, negative 3. Negative 2, 3, negative 1. Okay, and then set up the B matrix. 5, 3, 1. Okay, so I suggest you color this cells to show that these are matrix. Okay. Okay, so let's find the inverse of A. Now the trick here is you should know the size of your expected matrix. So we're now operating in a 3 by 3 matrix, right? So this is a 3 by 3. Therefore, the inverse of A is also 3 by 3, right? So I'll prepare a 3 by 3. Okay, I'll change color of that. Okay, see. So set up a 3 by 3 matrix, but technically this is not yet a matrix. Okay. Okay. So select that first. Select this 3 by 3. Okay. And then uh, while selecting, press equal. Okay. So equal and then type in MINVERSE. Okay, that's MINVERSE. And then open parenthesis. So the function will require you an array, as it says. Okay. So the array is the matrix. Okay. So that's the time you will now call this a matrix. So in Excel language, it's an array. Okay. So open parenthesis, and then I'll select this cells, which is now an array. Then close parenthesis. Okay. Okay, and then make sure you press Control Shift and then enter. So you press the 3. Okay. So to get to fully utilize this formula. Okay. So that's it. Control Shift enter. Okay. So that is now the inverse of this matrix above. Okay. So now to get the unknown matrix, okay, again, our general formula is AX equals B. Okay, in matrix topic, if the size of A inverse is 3 by 3, what will be the size of the B? So this is 3 by 3, and the B is 3 by 1, right? 3 by 1. So compatible, right? So they are both 3. Therefore, the final size is 3 by 1. So what's left is 3 by 1. So you need to prepare a 3 rows and 1 column. Okay? So to be consistent with this. Okay, so I'll prepare 3 by 1. So which is this. Then I'll color this one. Okay, so this is my expected size of the matrix if I operate the A inverse multiplied by B, so which is 3 by 1. So select the 3 by 1 cells and then press equal, and this time type in mmult. Okay, so you will see the definition of mmult over here. Returns the matrix product of two arrays. Okay, then open parenthesis, and then it says here select two arrays. That means the inverse A and then the B matrix. Okay, in order. Okay, mmult, our first array is the inverse of A, and then comma, our second array is the B matrix, and then close parenthesis. And what do we press again? Control Shift enter. So Control Shift enter. So see, in an instant you have the solution of your equation, of your unknown system of equation, which is this. Okay, here's that. Okay, so we were able to solve this system of equation using Excel, and what we showed earlier is using Kramer's rule. Okay.